Hello everyone, today we're going to see a topic in gate programming and data structures. Topic recursion. You got 1 minute to solve. Okay, so let's now review about recursion. So what is recursion? If you're familiar with the term, it is basically a function calling itself. So now in the normal function calls that we saw, right, in the video function, if you check, there is only one function call happening, that is one at a time. And if you saw in loop, we have this repetition. So now in the case of recursion, we're able to call a function more than once. How this happens is that in the function body, the function is calling itself. So now you must be thinking how this exactly takes place. So when we say that the function is calling itself, think of the data structure stack. So one time the function is called, a copy of the function is pushed onto the stack. Next time the function is called, another copy. So like this many times, new copies of the function are created and they're pushed to the stack. There is one main idea on this. So you must be thinking that if the function is calling many times again and again, won't it end in an infinite loop? Like if you saw in the case of for loop, if there is no condition, what happens? We have an indefinite loop. So here is the same case. So without your base condition, suppose if n is greater than 0, if you don't have this base condition, then the function call will happen infinite times. So now let's have a look at the question. So in the question, we can see that there is a function foo and there are two variables n and r. Remember that with each function call, we'll be having a fresh set of variables. That is, if we have two n and r, right, two variables, this call and next connection call variables will be different. They won't be the same memory. Just think like the local scope. Every time we call the function, it will be a new copy. Both are independent of each other's. Now let's look into the question. So first time we're calling foo of 345, 100. So n gets value 345 and r gets value 100. These are the local variables. Now we check. This is our base condition. So now we are checking if n is greater than 0. Return n mod r plus foo of n by r. So n mod r returns the remainder plus foo of a new function call. So next time the function call happens, n becomes 34 and r is 10. So again n mod r plus the next function call. So n is 3 and r is 10. So next time we're calling 3 plus the next function call. So next time when we call, n becomes 0 and r is 10. So now note here, this condition, right, what we're checking, n greater than 0, it becomes false. So what happens is that we go to the second statement. It returns 0. So now return, right? We reach the end of the function. That is the function termination. So we exit out of the function. So every time function terminates, that particular copy is popped out of the stack. So this doesn't exist anymore. Now, in place of this function call, whatever we had, right? We have 3 plus 4. So that will be replaced by the value returned, 0. So then similarly, this gets popped off, returns a value, and finally we get the value, return value as 12. So note here, every time the function call, right, whenever we were checking this condition and whenever it is calling, right, the execution, wherever we are, right, it is stopping from here and it is changing its execution to the next function call. And the rest of the statements only take place when the function execution, this call is done. So note this in recursion that in between the function execution stops at that point where some call is there, it goes to the function. Once that's done only, it returns back. So you have a set of statements, you call the function. So this takes place, then when this call happens, the function execution happens and then only statement S2 will execute. Let's overview whatever we learned today. So what is recursion? You're repeatedly calling the function till that base condition becomes false. Otherwise, it goes into an infinite loop. So remember, we were talking about the base condition, right? Suppose if n is less than 0, returns a value. So this is what we call as a base condition. It will tell when the recursion to terminate. If this is not there, this will lead to an infinite loop. So now you must be thinking, if we were calling the function infinite times, right, there will be infinite copies. So this, when this happens, this is what we call as stack overflow. That is, there is some sort of memory overflow what happened, that the space, there is no longer space for any more function calls to be added. So always note to add a base condition so that we don't end up in an infinite loop and get the stack overflow error. So each new function call is added to the top of the stack and each invocation gets a fresh set of variables independent of previous set. So note that since this is a stack, we'll always be adding it to the top of the stack. Every new call gets added to the top of the stack. And it is removed from the last to the first call. It is following the LIFO sequence, that is the last in first out sequence. So again, let's have an overview of the question. So when finally that condition becomes false, it returns. So we keep returning the value till the first function call is removed from the stack and we finally get the answer as 12. Thank you.